Okay, so today's video, I'm going to show you what we proposed for our project proposal when I was in senior design. So we had a summary. We went over a background, management, problem statement, our functional requirements, deliverables, technical approach, and we ended with a conclusion. So we provide some background of what our project is, VIP UHCT, vertically integrated project, University-wide drone technologies. It's a multidisciplinary group. We have members from freshmen to seniors in various different types of disciplines: computer, electrical, and mechanical engineering. We were part of a competition that was AVSI, Association for Unmanned Vehicle System International. And then we're going to go over our mission statement. So I explained that VIP UCT we formed in spring 2014, founded by these two gentlemen, Jonathan Liang, Justin Yoshimoto. And the goal that we had is to pass on knowledge to future teams. This is not really a good goal, but it's what we presented at the time. So we provide some more background about the competition, started in 2002, and the goals were to stimulate and foster interest in unmanned systems, technologies, and careers, or drones. So our mission statement was the purpose of VIP RCT is to effectively create an autonomous UAS, which is an unmanned aerial system that successfully performs all expected mission tasks of the AUVSI competition. So here's our breakdown of our team's organization structure. We propose to have a quad rotor team and a fixed wing team. So the fixed wing team would be like an airplane kind of drone. The wings don't move around. It's just fixed, doesn't flex around. Quad rotor, this is like the quadcopters, the DJIs, those kind of drones. Each team would have a team captain, a deputy, and a system integrator. And then the team captain kind of oversees a lot of the performance stuff, technical stuff. On the top level, we have the program manager, and then they would look at finance schedule and doing like public operation, things like that, marketing, advertisements. And then we had different subsystems. There's aerodynamics, focuses on like the structural part, the frame, actual body. Then we have electronics. This focuses on obviously all the electronics of the drone. Image processing. This deals with competition tasks. You have to use a camera, take pictures. Then you have like a flight or pit crew, like your pilots, the guys who are going to be flying the drone, looking at the ground control station, and getting back data in real time. So the problem statement we had is we need to construct a drone that performs a set of tasks without using humans. And that would be generating lift, overcoming gravity, producing thrust, reducing drag, and providing power to go forward. So the benefits for drones, well, it's cost effective. You don't need a pilot, it's unmanned. You don't need as much maintenance because it's a smaller aircraft, and you can access remote locations that are hard to for people. And you don't have to risk human life either. So how did people use drones back then? And they kind of still do, right? You can do search and rescue operations. If there's a flood in Texas, you can send out a bunch of drones, look for people. You want to observe physical phenomenon like the lava flow on Hawaii Island or the Big Island, you can do that. If you want to look at infrastructure, you can do that, as well as doing package deliveries. So there are some issues with having drones. So there's privacy, that's a big concern. At the time, someone in Kentucky shot down a drone. They thought someone was spying on him. There's also safety concerns. So if you have like a big fire and you don't want to endanger firefighters, you can send drones instead. There's also a lot of regulation of rules about flying drones that the FAA had. So there's a lot of things you have to follow. We didn't really explain any of it. So one of the questions we got is what are the regulations? And we didn't know at the time. So here are our function requirements. They're supposed to be quantifiable, objective, measurable. So the first one must be less than 55 pounds, very clear, straightforward. Not fly faster than 100 knots indicated airspeed. Your maximum mission time is 45 minutes. When you're doing the mission, you can only fly between 100 and 750 feet, mean sea level or MSO. You have to be heavier than air, so you can't have a hot air balloon or things like that. And then you can't have any tethers. So we wanted to do two tasks, an autonomous flight task and a search area task. So autonomous flight task, you have a controlled takeoff, could be manual, and then you need to do autonomous flight so the pilot is hands off. You need to go to all these waypoints like A, B, C, D, whatever, and you maintain that flight path. And you have a controlled landing. And then you need to maintain constant communication between the drone and the ground station. So you need to show like the flight data, where the drone's location is, and then all those waypoints where you're going. and then also the no-fly zones where you're not supposed to go. That's like a big boundary. The other task we wanted to do was the search error task. So you're going to find all the standard and then the quick response code or QRC targets. Then you need to classify all the standard targets and all the QRC targets. You're going to capture a bunch of images of those targets on the ground. Then you search this big area for those targets autonomously without the pilot doing anything. Then you decode a secret message, and then you send the link from those QRC targets to like the internet or something. So notice that we didn't explain what the target looks like, how big is it, what colors there are. So those are all the questions that we were asked. There are also some secondary tasks. I'm not going to go over this, and we didn't really understand at the time when we were presenting. We want to deliver 3 different subsystems for this drone. So for aerodynamics, we want to have a safe takeoff and landing, fly autonomously, fly in adverse weather, and then if you need to shut down the drone, then you need to prove that you can do that safely. So for electronics, we needed a gimbal system. So you have a camera mounted to the bottom of the drone, and it has motors to help the camera be stable. So whatever the drone does above, the camera won't move. We also need to make sure we had enough batteries and juice to last a long time to do all the missions. We needed to have good ESCs. These are electronic speed controllers. They send current to the motors. We also need different sensors. So notice this is extremely vague. We didn't really go into any of the technical details. We got asked a lot of questions about what this means. Then the next subsystem is image processing. We had to identify at least 2 characteristics of targets, and this would be like a letter or the color, the shape, things like that. And then you need to view the flight information from the ground station. So we also got a lot of questions because this was extremely vague, not really specific at all. And it's hard to understand what this is without seeing any pictures of previous targets. We provided some other charts. And then in conclusion, we just said our mission statement again. We summarized what we said here, and that was it. So as you can see, this is not a very good project proposal, and we did very poorly. So our introduction was like 7 out of 10. The strategy, the big picture was not very good, only 6 out of 10. As you can tell, we missed a lot of technical details, the background information, the context. So we got 4 out of 10. We didn't deliver very well because we're not very good presenters at the time. And so we got 6 out of 10. Conclusion was also pretty bad. So that was 3 out of 10. The time, we had a lot more time at the end because we finished too fast. So we got 5 out of 10 for that. And then visual aids, we didn't have a lot of pictures to provide the background context and information. So overall, we got 51.5 out of 100. So needless to say, this was a very bad project proposal presentation. So don't do what we did. Our introduction was just okay. We should have had like a bigger attention grabber, try to bring in the audience in. Why do we need drones? Why is this competition important? What does this mean to the university? The history of the organization, VIP, OHTT, things like that. For strategy and big picture, we didn't explain the competition at all. What's the purpose of it? Why are we going? Have we gone? How many teams go? This international, how many times other countries have gone? Which countries have gone? What kind of drones have they done? All those details we completely did not provide at all. So that was extremely bad. Then technical details, we didn't give, hardly anything about what do all those tasks mean? What does targets look like? The dimensions of targets, how long it takes to do all these different tasks. So that was a really big Docker for points here, 4 out of 10. Being good at presenting, yeah, I think that's self-explanatory. Conclusion, we didn't really end with a good way to convey, hey, this is what we propose to do. There wasn't a nice concluding statement of what we plan to do. And so the audience, including our fellow classmates in another project, they didn't really understand what kind of drone we were going to do or make or why this competition was important, but they were just left very confused. Even though we kind of just vaguely hit all these bullet points, but didn't have a nice cohesive story. And our visual aids were pretty bad. We could read the font. It was what light font on a dark background, which helps. But again, we didn't have any pictures to show the targets, how big the path is, what the competition field looks like. Is it at a military base, an airport? Is there grass? How long the flight path is, how big the no-fly zone is, all those things are missing. That would have helped the audience understand what we were doing.
Hi, I'm Andrew, Evan's assistant for Engineering 101. Let's summarize what Evan presented about his project proposal presentation when he was in senior design. The two main weaknesses are 1. Technical context and storytelling, and 2. Lack of visual aids. Despite covering bullet points, it was hard for the audience to follow because it lacked a cohesive story. Therefore, it's extremely important to tell the story, problem, and technical details by providing all the background context to help the audience understand your problem or competition and what you are proposing to do to solve the problem or meet the requirements to score points at the competition. Ultimately, the lack of technical details and understanding of the competition rules and scoring was the most critical missing component. The lack of visual aids hinders the audience's understanding, making it hard to follow. The absence of pictures created more questions than answers, but could have shed light on topics like the shape and color of the targets, the size and location of the no-fly zones, what is a waypoint, the location of the nominal paths and trajectories, the size of the search area, the competition's location, and the type of terrain. Describing everything verbally without pictures fell short, so it is crucial to use visual aids to quickly convey information effectively and efficiently. Don't forget that a picture is worth 1,000 words, and a video is worth 1,000,000. Overall, the presentation received a low score of 51.5 out of 100, indicating significant room for improvement. Evan's team could have had a much better presentation had they addressed these two weaknesses of 1. Technical context and storytelling, and 2. Lack of visual aids. They also could have done better had they closely followed Dr. Sharoma's delicious recipe for proposals that I described in a previous video. I'll repeat it to refresh your memory. First, what's the basic problem you're trying to solve? Second, how have others solved this problem in the past? Third, what are their solutions' shortcomings? Fourth, what is your proposed solution? Finally, how does your proposed solution overcome the shortcomings described above? Okay, that's all for this tutorial. Good luck presenting your proposals, and hopefully, you can learn from these mistakes.